Hello students, this is Miss Dalton and this is video 8.4, finding all polynomial zeros. Okay, since we're going to be finding all of the zeros, you will be finding some that are irrational or complex zeros, and so here is a little bit of information that you need to write down. Complex zeros, they always occur in pairs. They are called complex conjugates. And so what that means is that if a plus bi is a zero, then a minus bi is also going to be a zero. Here's an example. If 3 minus I is a zero, then 3 plus I must also be a zero of the function. Irrational zeros frequently occur in pairs with opposite signs. So for example, if the square root of 3 is a zero, it is likely that negative square root 3 is also a zero of the function. If the function is quadratic, the irrational zeros always occur in pairs. Alright, so here are your steps on finding all zeros. You're going to factor if possible to solve, set each factor equal to 0. If it doesn't factor, then go ahead and graph the function and choose a 0 from the graph or table. Use synthetic division to prove it is a 0, and then use your quotient from the first division to find other zeros. Remember that if a quadratic function doesn't factor, you may need to use the quadratic formula. If you do not prove a 0 from the graph or table using synthetic division, then you will not get full credit on an assessment. Alright, so let's look at example 1. We're going to find all the zeros of the function f of x equals x to the 5th minus 4x to the 3rd plus x squared minus 4. So the first thing I'm going to do is, since it does have 4 terms, I'm going to look to see if I can factor it by grouping. So if I do grouping, what I'd want to do is I'd want to group the first 2 together and the last 2. Now, it will factor if, when you take out the GCF, the remaining are the same. So for example, here I can take out an x to the 3rd, so I'll have x to the 3rd, and then when I divide that out, that'll be left with x squared minus 4. Okay, well you can see that that is the same as this leftover, so I'm just going to put that plus 1 on the outside because there's nothing I can divide out of that. And now I'm going to group the like ones together. So that'll be my first factor. And then the outsides come together as the second factor. Okay, now one thing I notice here is that this is a difference of squares, which is going to factor as x plus 2 times x minus 2. This right here is a sum of cubes, and so if you remember from your pattern, which again we'll have those, you'll have those on a test, but the pattern is that you take what cubed gives you the first term, so x, and what cubed gives you the second term, 1, and the first sign is going to stay that, and then you'll have the a squared, so that would be x squared. Then you'll have minus a times b, so that'd be 1 times x, which is just x. And then you have b squared, which is just plus 1. Alright, so all of these 3 terms at the beginning I can just set equal to 0 and solve. But this last one I'm going to have to use the quadratic formula on. Okay? So my first, I'm going to write them up here. So my first 3 zeros are negative 2, positive 2, and negative 1. So now let's use the quadratic formula on the last one. So that's going to be the opposite of b, which would be 1, plus or minus the square root of b squared, which would be negative 1 squared, which is 1, minus 4 times a times c, all over 2 times a. Alright, so if I simplify that, that's going to be 1 plus or minus the square root of That would be 1 minus 4, which is negative 3, all over 2. Okay, so simplified, that's going to be, I'm going to go ahead and put it over here with the other zeros. So that's going to be 1 plus or minus I square root 3 all over 2. And those are all of your zeros. All right, let's look at example 2. So this one says find all the zeros of f of x equals x to the fourth minus 2x to the third minus 3x squared plus 2x plus 2. This particular problem has 5 terms, and so I'm not going to waste my time with just trying to factor that. But what I am going to do is I'm going to put that into my graphing calculator and find some of the whole number zeros. And so when I type that into my graphing calculator, it looks like it has 2 whole number zeros, 1 and negative 1. So I'm going to take one of those and I'm going to use synthetic division. So I'm going to divide it by 1. So get your coefficients written down, make sure that you're not missing any. So it doesn't look like I'm missing any. So I'm going to have 1, negative 2, negative 3, 2, and 2. So bring down your 1. 1 times 1 is 1. Negative 2 plus 1 is negative 1. Negative 1 times 1 is negative 1. That would be negative 4. Negative 4 times 1 is negative 4. And then that would give me negative 2. And negative 2 times 1 is negative 2. And so you can see that that is in fact a 0 because it has a remainder of 0. Now I also had another one, another 0, another whole number 0 at negative 1. So I'm also going to use synthetic division with the negative 1. So bring this down. So you'll have 1 times negative 1, which is negative 1. That would give you negative 2. Negative 2 times negative 1 is 2. Then you add those up. That would give you negative 2. Negative 2 times negative 1 is positive 2. So you can see that that is a 0. Now what happens here, the reason why you want to do that is because now this gives you a smaller polynomial to work with to maybe factor or use the quadratic formula. We're probably not going to factor because if we factor, then it would have given us a whole number, or you know, maybe a decimal, but we'll probably go ahead and use quadratic formula. Now when I divided it the first time, since I started with x to the fourth, then this would have started with x to the third, and then when I divide it again, that means that this would have started with x squared. Okay, so let's go ahead and look at this. So now we have a quadratic that now we can use the quadratic formula on. So I'm going to do that over here. We're going to do the opposite of b, which is 2, plus or minus the square root, b squared, which would be 4, minus 4 times 1 times the c, which is negative 2. Okay, and that's all over 2 times a, which would just be 2. So go ahead and simplify that. That would be 2 plus or minus 4, and that would be plus 8. So 4 plus 8 is 12. So this would be the square root of 12 all over 2. I can simplify the square root of 12. I can break it down to be 4 times 3, and then I'll be able to do the square root of 4, which is just 2. So this would be 2 plus or minus 2 square root 3 all over 2. Then look at that magic triangle, see if you can divide anything out of all of those numbers, which you can. So it would be 1 plus or minus the square root of 3. Alright, so those are 2 of our zeros, and then remember the ones we started with. So we also have 1 as a 0 and negative 1 as a 0. And those are your final answers. Alright, example 3. So find all the zeros of f of x equals x to the fourth plus 15x squared minus 16. This is a trinomial, so I could look to see if I can factor it. Now don't be thrown off that that first term is an x to the fourth. When you factor an x to the fourth, your first term is just going to be x squared. Okay? Now, can I factor it where I have factors of negative 16 that add up to 15? So that would be plus 16 and minus 1. Okay, so those are your factors. This first one, x squared plus 16, the only way you can factor a quadratic that is two terms is with a difference of squares. This is a sum, so I'd have to use quadratic formula on that one. But this one here, x squared minus 1, it will factor to be x plus 1 times x minus 1, which then I could write down what the zeros are of that. The zeros would be negative 1 and positive 1. Okay, so there's two of my zeros. Now let's go ahead and use the quadratic formula on the x squared plus 16. So negative b, which would be just be 0 because there's not a b term, plus or minus the square root, b squared, which would be 0, minus 4 times a times c all over 2 times a, which would just be 2. So all I need to do is take that square root. I will have the plus or minus, but that 0 is not going to be anything out front. Negative 4 times 16 is negative 64, so this is going to be negative 64 all over 2. So this is going to be plus or minus 8i over 2, which would simplify to be plus or minus 4i. So there are my solutions, plus or minus 4i, negative 1, and positive 1. Now let me add here that if you didn't recognize that this factored at the beginning, you can always go to your graphing calculator and look for some whole number zeros and then use synthetic division like I did on that previous example to get the polynomial down to something that you can use the quadratic formula on. Alright, this last example is written a little bit different. It says write a polynomial of least degree with rational coefficients, a leading coefficient of 1, and zeros of negative 2 and 1 minus 3i. Now the first thing that I recognize is that 1 minus 3i is also going to have its complex conjugate, which is 1 plus 3i, as a solution, or as a 0. Okay, so I'm going to take these zeros that I'm given and I'm going to write them as factors. Now when you write them as factors, they go in with x minus that 0, so I'll have x minus a negative 2, which is going to be a plus 2. Then when I do x minus, I'm going to put this in parentheses, minus 1 minus 3i. And then I'm also going to have x minus 1 plus 3i. Now I put those in parentheses on purpose because you are going to have to distribute that minus. So you're going to have x plus 2 times x plus 1, or I'm sorry, minus 1 plus 3i. And then you're going to also have x minus 1 minus 3i. Okay, now what you're going to do is you're going to multiply these together. Now I'm going to choose to multiply the complex factors together first. And so watch me pretty carefully on this because it's going to be kind of interesting. You're going to take x times x, so you're going to FOIL, so that's going to be x squared. Then you're going to do x times that whole thing, which is just going to distribute the x to it. So it'll be negative x and then minus 3ix. Then you do the inside, which will just distribute the x to -1, so negative x, and then also to the 3i, so plus 3ix. Okay, then this last part is probably the trickiest part. So you're going to take, and I'm going to write it over here, you're going to take -1 plus 3i, and you're going to multiply it times -1 minus 3i. So you're going to FOIL it. So that's going to be -1 times -1, which is 1. Now I'm going to write it above it, actually, because I don't want to run out of room. So that's going to be a 1 when you do -1 times -1. Then you're going to do -1 times -3i, which is just positive 3i. Then you're going to do the inside, which is just -3i. And then you're going to do positive 3i times -3i, which is -9i squared. And you remember what happens when you have an I squared. This just becomes -1, so that'll be actually positive 9 there. Okay? Now, the -3i and the positive 3i, they cancel. So you really just have 1 plus 9, which gives you 10. So that's going to be what I put on the end here. And really that should always happen where that inside 2 cancel like that. So just FYI, you might want to keep that in mind. Alright, now when I look at this, I need to simplify it. So the -3ix and the positive 3ix, those cancel. I'm going to collect my like terms here. So I'm going to have x squared. Then I'm going to have minus 2x. And then I'm going to have plus 10. Alright, so that's what the last two multiplied together becomes. But I also need to bring that x plus 2 down and now multiply x plus 2 times that to get my final polynomial, which will have those all multiplied together. So when I do that, that's going to be x to the third minus 2x squared. Then I'm going to have x times 10, which is 10x. Okay, then I'm going to do the 2 and distribute it through. So 2x squared, I'm going to put that underneath here. And then negative 4x and plus 20. Okay, go ahead and simplify that. These cancel. So I'm going to write my final answer up here. You have x to the third. Then you're going to have a plus 6x. And then plus 20. Alright, so we've written it with least degree, with rational coefficients, and it has a leading coefficient of 1, and so this would be your final answer. So really on these problems, all you have to do is write down, all of your zeros, make sure you put any that are missing, and then you just have to multiply all those factors back together to get it in standard form. Alright, so this was a pretty lengthy video. Please come to class with your questions so that I can get them answered.